Hello everyone. Today I will talk about our Hyperloop vacuum tree. It can take you from Kuala Lumpur to Singapore in 15 minutes. Nowadays, faster travel is important. Kuala Lumpur and Singapore are big Asian cities. People go there for work or trips, so we need a better high-speed transport. As electronic students, we designed this vacuum pump tree. It runs at 1,000 km/h, so the trip is just 15 minutes. Let's share the three key points. First, one is air resistance by the full speed. The faster something moves, the more air pushes at it. If speed doubles, resistance is four times bigger at 1,000 km/h. Most in region fight this resistance, so air stops us from going super fast. That's why we use vacuum pumps. Second, are vacuum pumps safe? Yes, they face hard atomic freak, but sure. We use strong carbon fiber and splice the pulp into sections. There are sensors to send real-time data and emergency for problems, so it's safe. Third, how to keep the motor cool in vacuum. Uh, Three ways use materials like chopper to move height out, run coolant to absorb height, use height resistant motors and low height motors. That's the first three parts. Thank you for listening.
Okay, today I will talk about two things: vacuum pipes safe and motor cooling in a vacuum. First, about the vacuum pipe. The pipe must be very strong because air pressure outside is very high. Um, to solve this, we use carbon fiber, which is light and strong. The PEEP also has ring support to make it stronger. The long PEEP is divided into many uh, sections, not one wheeled PEEP. Uh, each section has sensors to check pressure all the time. Um, if something goes wrong, pressure relief valves can reduce danger. So the vessel PIP is safe and con- controllable. Okay. Okay, next, about motor in a vacuum. Uh, in a vacuum, there is no air, so the motor cannot cool safety, cannot cool easily. Um, it if it gets too hot, it may melt to break. Um, we use three ways to solve this problem. First, we can see first is passive cooling. We use materials like copper to move heat faster. We also use black surface to send heat out by radiation. Second is Liquid coding. A special coding liquid follow inside the motor. Uh, it take it takes heat to radiator planters outside the tube. Third is the better materials and design. We use high uh, tem- temperature. We use high temperature metals and good insulation. We also design most that make let heat. In short, strong pips keep the system safe, and good cooling keep the motor working. These two pips are very important for high-speed vacuum uh, transport. Okay, that's all.
A topic about the safe stop steam for Mach 0.9 per on our cabin. So first, let me say the common procedure of the safe stopping system relies on the combination of magnetic braking and regenerative braking. The magnetic braking generates aids current resistance through electromagnetic induction to declarate the carbon. So, well regenerative braking converts the kinetic energy of the moving carbon into electrical energy for recharging. So for emergency service, a backup stopping sim is configured on segmented electromagnetic declaration. Yeah, declaration track the work in conjunction with friction brake pads installed at the bottom of the cabin to achieve urgency declaration. Yeah, so the design of magnetic braking efficiency and the key parameters in the vacuum power plant should be optimized in combination with the control rate limit to ensure the stability and reliability of the braking system and the high-speed operation conditions. Yeah, let me say next. Wait a minute. Let me see the picture. So in the world discussion of the sprays and the overcoming of technical difficulties, we use a variety of precise electronic instruments such as superconducting meters, magnetic braking, senior monitoring, etc., which played a crucial role in the development of the project in train safety. Yeah, so the FNC intelligence and other aspects, and it's not difficult to see from the content of the poster that the wide application of electronic and electrical technologies in various fields. However, the idea is often beautiful, but based on the high amount of work of this project, it may cost tens of billions of dollars and countless attempts and trials and errors by researchers to succeed. And whether the current scientific researching technology can meet some of the required technical requirements is also a major difficulty. However, in the near future, if this technology is realized and put into use, it will definitely promote the long-term development of both places. At the same time, these technologies will also become a great leap forward in the historical process of high-speed railway. Yeah, that's all. Thank you.